So in this note sheet, we're looking at two-step equations. More specifically, how can I use the inverse operations to solve an equation for a variable? Before we start getting into the solving the math part, there's a lot of important vocabulary that we need to think about. The first question says, what is an equation? An equation is a mathematical statement that says two expressions are equal. So that's where that equal sign comes in, which makes it an equation. Then we have these different parts of an equation. We have variables, which are our letter. A lot of times they use X, but they might use Y or A or B or M, so on and so forth. Let me just focus this right here. Okay. Second part of our equation is the coefficient. The coefficient is a number that's placed in front of a variable, and it's used to represent multiplication. The coefficient is like the best friend or the co-pilot for the variable. They're always right next to each other. A constant is a number by itself. It does not have a variable. So constants are the numbers that do not have letters with them. So if we look at this equation, there are three arrows pointing to three different parts of our equation. Ask yourself what each arrow is pointing to. Is it pointing to a variable, a coefficient, or a constant? Label those arrows. For 4, since it's right next to our variable and it's used to tell us that they're multiplying 4 times x, the number 4 is our coefficient. Right next to our coefficient we have that x. Since that's a letter, that is our variable. Oops. Variable. And last but not least, this 8, since there's no letter here with this 8, that makes this a constant. So knowing those parts of an equation, those words, is really important when we're starting to talk about, eliminating constants, removing coefficients. That way you know what those words mean so that you know what we're talking about. Now we get to the actual solving part. So when we solve an equation, all it means is that we're finding the answer. There's a specific word for the answer to an equation, and that word is solution. In science class, you talk about solutions, but in math class, a solution is just the answer to an equation. Now, when we are solving an equation, your job is to isolate the variable. You'll hear me say that a lot. What this means is to isolate, or to get alone, get by itself, the variable. So we are getting the variable alone, or by itself, whichever way you like to say it. And so what we will be doing to get that variable isolated, to get that variable alone, is we are going to use the inverse operations to remove or to erase the coefficients and constants in the equation. Now the word inverse is important. Inverse just means opposite. So we'll be using the opposite operations. The last important part to make here is on the bottom. And what this says is what we do to one side of an equation, we must do the same to the other side. So here's an example on the bottom. We are asked to solve this for x. So the first thing that I'm going to do, and I know you've been taught to do this by other teachers, is to draw a line down the middle. Now that creates our two sides. The other thing is we're going to put this in a box. That 4x is what we're going to do in our second step. We're going to save that for later. Think of this as a bodyguard. The x is Beyonce. Beyonce has a bodyguard, but she also has a security team. If you were to, let's say, get tickets to go see Beyonce backstage, you would have to pass through security to get backstage to where her and her bodyguard would be. So we always take care of what's right next to the variable is always at the end. So our first step to solve this, since this is minus 8, we're subtracting 8, the opposite of that, we're going to add. And notice how I'm adding that to both sides. Negative 8 plus 8 is 0, so we've effectively gotten rid of that. It is now gone. 20 plus 8 is 28. What we have left over on this side is that 4x equals. 4x means 4 times x. There's that little multiplication symbol in there that nobody writes. So we're going to do the opposite of that. Opposite of multiplication is division, so notice how I'm doing that on both sides. 4 divided by 4 is 1. So that's what we want to get. We want to get it to be 1x. So 1x equals 28 divided by 4, which is 7. So this means that our answer is 7. Okay. We never write the 1x because, like I've said before, mathematicians are lazy and they don't want to have to write anything extra. So what I'm going to do now is walk you through the examples on the back. So here we have our first one, 14 minus 3x equals negative 13. Again, I'm going to draw that line down the middle. I'm going to put this negative 3x in a box. It's really important that we include the minus or the negative sign in front as well as the 3x. Now this 14, sometimes we get confused and we don't know whether we should add or subtract. Since there's nothing here, there's really a ghost plus sign, meaning that that's a positive 14. So when we go to do the opposite, to get rid of it, we're going to need to subtract, or do a minus 14. Plus 14 minus 14 will be gone. We'll still have this negative 3x. Negative 13 minus 14 is negative 27. Since this means negative 3 times x, again we are going to divide. Divide both sides by negative 3. This will give us that 1x. So x equals negative 27 divided by negative 3. Since we're dividing by both numbers that are negative, our answer is going to end up being a positive 9. With our second example, it's the same idea. I'm going to draw my line down the middle. This y over 7 is going to end up being my second step, so I'm going to save that for later. Since that's a plus 8, we will do the opposite and subtract that 8. Plus 8 minus 8 is gone. 5 minus 8 is negative 3. And so now my second step, since this is y divided by 7, the opposite of that is going to be to multiply. So we're going to multiply these both by 7. That will eliminate this division here. We'll just be left with y equals negative 3 times 7 is negative 21. In our third example, we don't have a number in front of this x. And I know when we did expressions, we talked about that ghost 1. That ghost 1 is going to come back. So I'm going to put a 1 in front of that x. Then I'm going to put a box around this. Since that's our coefficient, we're going to worry about the coefficient at the end. First, I'm going to get rid of that 16. Again, since there's no sign in front of our 16, I know that that means that this is a positive 16. So I'm going to do the opposite and subtract, or use a negative 16 to get rid of that. It's really important that I copy down negative 1x. 12 minus 16 is negative 4. So now some of you might know that that just means that x will be positive 4, but if not, we can always divide by negative 1, which is our coefficient. Negative 1 divided by negative 1 is a positive 1. Negative 4 divided by negative 1 is positive 4. And so that is our final solution. This next one that we're going to do is a little bit weird. It's a little bit tricky. Because this is like a big fraction. So when we look at an equation like this, we have to put a box up around the top. That's the numerator of our fraction, and we can't do anything with that until we've gotten rid of the fraction part itself. So since this means divided by 6, our first step is going to be to multiply by 6. And so that way we can get rid of it. This multiplication is only to get rid of this division. So we're not going to do 6 times x or 6 times 5. Just eliminate the fraction. So what we're left with is what's on the top. And that equals 12 times 6, which is 72. Now I am doing addition, x plus 5. So to get rid of that plus 5, I would do the opposite and subtract. So x ends up equaling 67. So I put a star here because this is a kind of a different example. It works a little bit differently than the other ones on this page. With this example, there's a couple of tricks to this. We're going to deal with this part at the end. So let's worry about that later. Right now, we're just focused on this minus 2, or this negative 2. The opposite of that would be plus, or to add. And it's really important that I copy that negative 5 when I bring my work down. So again, this means that they're dividing by negative 5. The opposite of that, we're going to multiply. But it's really important that we multiply by negative 5. That's the only way that we'll be able to get rid of that totally. And so over here, 8 times negative 5 is negative 40. And so that's our final answer. Last example in this section. Sorry about that. What we're going to do, just like before, we're going to put a box around our variable and what's closest to it, that coefficient. But it's also really important that we put in that minus or that negative sign as well. To get rid of that 17, since it's positive, we're going to subtract. We do have a negative 17. So that will go away. Now, when we copy this down, this y over 3, since it's a negative y over 3, we're going to make that 3 on the bottom a negative. And that's going to equal 10 minus 17, which is negative 7. Since this means that we're dividing, just like we did over here, we're going to multiply. But it's really important that we multiply by that negative 3. And we don't lose that negative sign in our work. So that will go away. Y equals negative 7 times negative 3, which is a positive 21. So those are all the different types of two-step examples that you might see. The ones that we have below are also two-step equations, but they also have fractions. And so I know a lot of times when we see fractions, we get really nervous and we freak out because they're hard. But there's something that we can do where in one step, in like 10 seconds, you can do something that totally eliminates all those fractions. And it's going to be multiplying. We're going to multiply everything by a common denominator to get rid of those fractions. For example, we're going to end up multiplying this entire equation. When I look here, oh, there's only one denominator because there's only one fraction. Since the denominator is 3 and there's no other fractions, our common denominator is 3. So now we're going to multiply. 3 times 2 divided by 3. Well, 3 times 2 is 6. 6 divided by 3 is 2. It's going to become 2x. 3 times 7 is 21, and that equals 3 times 15, which is 45. And now my new equation has no fractions. I've gotten rid of it. I'm going to put a box around my variable and my coefficient. I'm going to get rid of that 21 first. (45 minus 21 is 24). I'm going to divide by 2. X equals 12. And so we got rid of that fraction, and it made our lives a lot easier. With this next example, we're going to do the same exact thing, but there's two different denominators. We have 8 and we have 4. So we have to find a common denominator. The easiest way to do this is to count by each number. If we count by 4s, we'd have 4, 8, 12, 16, 20, and so on. If we count by 8s, 8, 16, 24, 32, and so on. What we're looking for is a number that's in both lists. So looking at the list that we have, I see that 8 is in both lists and 16 is in both lists. A wise piece of advice is to pick the smallest number. So we're going to pick 8. That's going to be our common denominator. So we are going to multiply all of this by 8. 8 times 10 divided by 8, well, 8 times 10 is 80, divided by 8 is 10. 8 times 3 divided by 4, 8 times 3 is 24, 24 divided by 4 is 6. So it's going to become 6x equals 8 times 11 divided by 4, 8 times 11 is 88, 88 divided by 4 is 22. And so now we're back to a regular or easier two-step equation where we can go ahead and solve. I'm going to worry about my coefficient at the end. First I'll get rid of this 10 by subtracting. 6x equals 22 minus 10 is 12. Divide by 6. X equals 2. And so those are some notes on two-step equations. We'll do some activities to practice this a little bit more. But if you're needing help on this, there are other videos online that might help, or you are more than welcome to stay after school with me.